exceptional.
Yeah.
Right? I mean, it's. Anyway.
I think we'll get started.
Yes.
Maybe finish the conversation after.
Yeah.
Yes.
So there's a mic here.
I'm going to do a short intro. Is there something you want me to say? Or?
Feel free.
All right. Welcome, everyone. Thank you for being here. So it is my pleasure today to introduce Professor Wendy Mackay. So Professor Mackay is a research director, class exceptionnel at Saclay in France. And she leads the ex situ research lab. Might have known of in situ before, now it's ex situ, in human-computer interaction. So she is an HCI pioneer, and that's not me saying that, it's Ben Schneiderman. No. And so, of course, as an HCI pioneer, she has a lot of honors and awards. She received a lot of honors and awards over the years. So to cite a few, she received both the ACM Mackay Lifetime and Service, Lifetime Service and Research Awards. So it's very impressive. She was also the annual chair for computer science for the Collège de France. That's a pretty big deal in France. She's also a member of the Mackay Academy and an ACM fellow. So she has published over 250 research articles in the area of HCI. So I'm sure you all know some of her work. I mean, maybe the people who are more in AI might not have heard so much of it. I know my students have heard of her work because I always annoy them with that. But you might have heard of like technology probes. It's one of her most cited work. Her theory of co-adaptation, or her work with Professor Michel Baudouin-Lafont on instrumental interaction and generative theory of interaction. So today she's actually going to talk about some of that. And she's going to show how we can use those theories in her work to create human-computer partnerships. So without further ado, please join me in welcoming Wendy Mackay.
Thank you, Damien. That's great. All right. So as Damien said, I am an HCI researcher. And of course, as an HCI researcher, lately we've been dealing with AI. And so, but this is actually work that started about 15 years ago, and I applied for what is called an ERC grant, a European Research Council grant, and it was about creating human-computer partnerships, and it's based on this idea that we want to think about not just how do human beings sort of delegate tasks to an AI, any kind of agent, but how do we actually collaborate with them, and what does that mean? And so I will get into that. All right. So let's do a little bit stepping back and thinking about something really basic. So Turing machines, a lot of AI is based on the idea of a Turing machine, and the idea is that you have some data and you calculate something and you produce a result. And that's great, except for Turing machines aren't really the right metaphor for dealing with human-computer interaction. Basically, the most basic thing that you do on a laptop, you do a double click, you can't handle that with a Turing machine. So what we're doing is we're trying to do a lot of calculation, but not really thinking about what's happening in the interaction loop. How do people actually interact with a computer? We have a situation in which people do things and the system does something and we go back and forth, all right? Now, the problem that we have also in thinking about typical AI systems, and I'm thinking of LLMs, and I'm thinking of what happened since ChatGPT with the idea, okay, we're all going to talk to computers, is that in fact we have different kinds of possible relationships with a computer. So one possibility is to think of it from my perspective, and I use it as a tool. So I can pick up a hammer and I can do something with it. A second perspective, this is what we would call the first person perspective. It's me and I control the tool. I'm in control. The second one is thinking about the computer as a servant. Basically, the idea is I delegate tasks to somebody or something different, and I don't have to worry about it. Or I assume control, maybe I check. That's more typical of an AI way of thinking about things. And a third kind of interaction that we have is thinking about the computer as a medium of interaction between and among people. And so when you think about social media, what you have is a space for interaction. Now, historically, those of us in HCI were basically building tools, and people in AI were basically building servants. And then along came social media, and we said, oh, that's cool. We can go from, video and media spaces and things like that, and we can create, Facebook and other things. And now what's been happening is they've started to all merge together. But I think it's helpful to think about it when we're designing interactive technology. Where are we on this spectrum? And when we're doing multiple perspectives, how do we manage that? So basically, human-computer interaction, for me, is the idea of thinking about human skills. What are we good at? We understand as much as we can about human perception, cognition, action, and also a set of system capabilities, which is like it can store information and it can calculate things, and there's input and output, all of that. But together, they create what we call interaction. And as somebody originally trained as a scientist, as a psychologist, we're trained to think about looking at phenomena that exist and studying them as phenomena. So here, the claim is that interaction is a phenomenon that we can study. Excuse me a second. Breathed in something there. Anyway, that's better. All right, so we have these different perspectives. We have an AI perspective and we have an HCI perspective. And it's important to kind of keep those in mind when we're designing actual systems. So a key insight that I had a number of years ago when I was talking to my colleagues in AI is that the goal of the research is fundamentally to improve an algorithm. And it is not to improve the user's interaction with that algorithm. And we do the opposite. And that has a fundamental impact on the kind of research that we do. So if you take an AI perspective and you're thinking about, oh, well, I do humans, I do human in the loop. Sure, I do. And how do you think of the human? What is the human to you? If the goal is to make your algorithm better, well, you can think of the human being as a source of data for your algorithm. Isn't that nice? Humans create all this stuff. You grab it and you use it. Makes your algorithm better. Okay, one use of human. Another one is people make mistakes. You know, there's all these biases. You go to diversity and Kahneman, and we can oversimplify what human beings do, and we create a whole set of sort of ways of thinking about human beings as errors to be resolved. And finally, they can just be a component of the machine. You might need them to go in and deal with something that you can't actually figure out how to get a robot or somebody else to do. So this notion of human in the loop is all about using humans to make the algorithm better. Now, the problem that we have with that is that a better algorithm is neither necessary nor sufficient to make a better intelligent system. And that's critical, because if you think that you've spent all this money and time and effort creating a better algorithm, and at the end of the day, you can't show me that you've got a system that makes life better for human beings, then you got a problem. And I think we have a problem. So you can look at two different algorithms with the same interaction, and you can get the same result. So what that means is I can have a very, very expensive, hard to compute algorithm and a very simple one. And if you create the right interaction with a human being, the result can be the same. So then you ask the question, why am I buying this really expensive algorithm when a very simple one could do? And sometimes the simple ones, the more deterministic ones, can actually work better. So there's that. On the other side, okay, so yes, here's the example. If you're going to add two numbers, you want a deterministic system. You don't necessarily want an LLM. There's all kinds of issues about that. Similarly, on the other side, you have the same algorithm, but if you provide a different interaction, you can produce radically different results for the user. So here the algorithm is not changing, it's just the interface. And we have examples such as our friend ChatGPT. So the original version of GPT-3 had a different interface, and very few people used it. some, tens of thousands, but still very few. And then when they shifted it to a chat interface, it took off, it exploded. We all lived through that. We saw how that happened. And so same underlying algorithm, different interface, radically different results. Are you gonna?
Can we take questions?
I think it's better to save them at the end because I'll never get through. I'm already late. But hold your question because this is designed to be a little challenging for the AI folks in here. All right, so I wanted to also highlight the fact that one of the things that we see happening is that AI is being introduced everywhere. And I say AI in the general term. I mean, LLMs are here and there, and it matters what kind of AI. But just for the sake of argument here, this kind of interaction turns the user from an author of information into a corrector of information produced by the AI. And so here's a lovely example. She says, just so you know, Dad's in prison. And the other person says, what? Are you joking? Why aren't you answering your phone? I'm freaking out. I mean, just so you know, Dad's interested. Oh, sorry, I was in the bathroom. Dad's interested in dinner tomorrow. Just took 5 years off my life. The idea is that these corrections are not rational. They don't think in the same way that people think. They are probability machines, and they produce things that are plausible, but not necessarily reasonable from a user's point of view. And so what we as human beings do when we look at the things that are produced by an AI have to be both thinking about, is it right? Is it what I meant? And is it also even remotely possible? In this case, not. All right, so what we want to do is take an HCI perspective. We want to reconsider the user's role, and we want to think about how can we build interactive systems where human beings benefit from that interaction explicitly. Not that some other large corporation benefits necessarily, but I think one of the things that we do as researchers is think, how do we have the people who are actually users of these systems benefit from them directly? And so we want to think of not human in the loop, but somehow algorithm in the loop. The idea is that the algorithm is a source of information for users. And ideally, what we can do is empower people. It would be nice if in using these technologies, people gain skills and they control the interaction. And that should be a fundamental goal of the kinds of systems and the methods that we use to produce these systems treat as a value system. So I'm going to throw in a little example on this side. This is just recent work from one of my students. And she was looking at how do data scientists use AI models. And the questions are really basically, do they go for the fastest, most interesting model, or do they try to get the model that will make the most sense to the users in the system? And as you can probably guess, it's not the latter. So mostly they're looking for familiarity, accuracy, interoperability, things like that. One of the things is that the people who were the younger data scientists were basically going after the largest, coolest model out there. It's like buying a fancy car, I guess. You want the one that really goes. And issues about things like sustainability or appropriateness for the user's perspective, not even in the equation. And there weren't any ways of them easily asking those kinds of questions. So if you go to, for example, Hugging Face, you can get all kinds of information about models. And if you dig deep enough, you can get some information about sustainability sometimes, but it's really not set up in a way that allows data scientists to think about what is the impact of using these particular models. So what do I mean when I say, okay, let's create these human-computer partnerships. Let's think about what it would mean to actually benefit users in this interaction. So let me define what I mean by a partnership. And I'm using transportation as a metaphor here. If I am, it's Saturday night and I go out for a beer or two or three, and I decide that I need to get home, it's probably better off if I delegate that task of driving to somebody else. That's not what I should be doing. However, if it's Saturday afternoon and I am really good at driving my motorcycle and I love my motorcycle and I like to play with it, then what I want to do is stay in control. And, you know, my metaphor here is I don't want a self-driving Ferrari. I didn't buy a Ferrari because it's self-driving. That's not the point, okay? So the question is, how do we get the ability for the user to make those choices, to not have it done in advance for us? And what does it mean to do it with some kind of intelligent being? So here, the metaphor shifts, and now we have a horse. Now, a horse is intelligent, but not in the way that humans are. It knows stuff that we don't know, and we know stuff that it doesn't know. You can grow up with a horse, the horse can get to know you, you can become a better rider over time. If you've been drinking on Saturday night, the pub is not too far away, then you can, you know, have the horse take you home, but you can also go riding in the afternoon and do all that sort of stuff. So the idea is that we want this kind of shared control where we respect and recognize the fact that each entity has different strengths and weaknesses, and that we design for that explicitly. That we don't just say it's all delegated to the horse, but that we share that with human beings. All right. So the way that we're going to actually make this happen is that we want to think about how to measure the impact of the algorithm on the human user. And we want to think about that impact not just in milliseconds at the moment they're making a particular choice, but what that impact is over time. And so if I think about an example such as, I remember Mark Zuckerberg sort of innocently, butter wouldn't melt in his mouth, saying, we didn't know that people would get addicted to the like button. Dude, anybody who takes Psychology 101, very first course, you know that's how the principles of reinforcement work, and of course it's going to happen that way. But that's something that happens over time. There's a short-term reward and a long-term, potentially very negative impact. And we can look at that over time as well as in general. All right, so for us as researchers, our challenge is, how do we deal with all of this? Now, there's another thing that we like to talk about, which is this challenge and the compromise between power of expression and simplicity of execution. So if I think about something like programming, I require a lot of expertise. I'm not talking about vibe coding. I'm talking about actually programming, writing your own code. This gives you tremendous power of expression. You can do lots of different things, but it requires a lot of investment on the user's from the user's perspective. If you have a button, you press it, very low difficulty, just press it, but it doesn't do much. And so the question is, how do you design systems and recognize that there's a trade-off? And there's all kinds of things in between those two. And we argue that the challenge as researchers is not to ignore that curve, but rather to shift it. So to try to build systems that are given a certain level of difficulty, we make them simpler to use and retain that level of power that they get from that level of difficulty. Or we take something that's relatively simple and we add power. And there's a wide variety of different systems that we've developed over many years that address this power simplicity trade-off. And a second thing that I want to say it's important is to think about, how do we think of this as scientific researchers, not engineers. We're not trying to just build systems. We're trying to think about interaction as a phenomenon, as something that we want to think about understanding. And that requires this back and forth between theory and observation. We have to understand what's happening in the real world and theorize about it. So this is us studying interaction as a phenomenon in its own right. So this is something that I worked out a number of years ago with a philosophy PhD student, Anne Feard. It's been over 25 years, a long time. But this one helps me think about how you deal with sciences versus sciences of the artificial. So in the natural sciences, if you think about what does a scientist do? Well, there is a transition. You start out, if you're a physicist, you publish an article and you say, this is my theory of how X works. There's a phenomenon out there. And then you run experiments to prove it. And then you go back and you revise your theory and you go back and forth. And it's a back and forth between theory and observation. And there are a lot of types of physics, types of biology, types of psychology that are operated that way. And I should say, this is how they publish their research, which feeds the stereotype of how this is done. But it is also important to recognize that there's a whole bunch of other perfectly legitimate natural sciences that start by focusing on the finding, the observation, and then theorize it. So if you're an astrophysicist, you don't do controlled experiments with stars. You just don't. You have to observe a nova and then figure out how to ask questions and theorize about it, and then look for other observations and so on. And the same is true in geology, anthropology. There's a number of these. And so what you've got is this idea that we are independent observers of phenomena that exist external to us. And we go back and forth between theory and observation, empirical work. And the way we talk about it depends on what discipline we're in, whether we start with theory and move to observation, or start with observation and move back to theory. But they all go back and forth. So that's lovely. Great. Except, all right, so these are some examples from human-computer interaction. Fitts law is a nice example of the start with the theory and observe, and distributed cognition is start with the observation and theorize about it. But now we have a problem. We're building technology. We are no longer unbiased observers of what's happening. That's not a phenomenon that's out there. This is something that is happening. We create it. We observe things other people create, and it is not independent of us. This is what Herb Simon calls sciences of the artificial. And the question is, how does that fit into this scientific way of looking at things? And it turns out that it all basically still works. You can take different paths. You can start with theory. A lot of AI is starting with sort of mathematical models and going through, but they're building, I don't have a pointer here, but if I do this here for those in the room, I can start here and I can go back and forth between models and artifacts and model artifacts and never really look here. And I can do things where I build a product and I say, oh, I built this product and can see whether it's out there in the market or not, and I can do that. But if you want to do research that's scientific, the argument that I'm going to make is that you have to make a complete loop back and forth. You have to have some theory. Theory can be about the artifact or the use of the artifact. You have to observe what happens when it gets used and maybe modify the artifact, maybe modify the model. You can start from the bottom, from the middle, or the top, but you should be doing a full loop because that's what makes it a complete scientific inquiry. All right, there's another thing that I want to point out since I'm throwing in a lot of philosophy at the moment. There's a guy that, Mark Wieland, who's written a book called Everything Evolves, which is a nice sort of popular summary of this. But the idea that he's highlighting, comes from other people as well, is that there are certain types of phenomena. There are phenomena that simply exist. And if you treat a human time scale, most of the physics we look at is like that, or the structure of the DNA. It exists independent of us, it's out there. And if I study it, and if Michel studies it, and Damien studies it, we'll all be studying the same phenomenon. There's a whole set of other phenomena that exist in the world that are evolutionary. Basically, they're contingent on what happened before. That is clearly true of evolutionary biology, which is an influence, but there's all kinds of other things. Like if you look at economics, political things, anything that where what you've done, it matters what was happened before. That's true of anything to do with human-computer interaction. If Steve Jobs had put this Macintosh out in the market in 1984 when he put out the first Mac, it never would have survived. It couldn't, because nobody would know how to use it. It's far too complex. But over the years, this increased complexity, there's all kinds of things that have happened, it's changed, and this is the result of an evolutionary process. And it's important to recognize that when we are studying and creating these phenomena, we have to recognize that there are elements that don't change, sure, but the important stuff is the stuff that does change. All right. I also want to say that there's different kinds of theory. What do I mean when I say theory? Social sciences tend to do descriptive theory. Basically, here's a phenomenon out there. I've observed that people do this or animals do that, and we describe it. Another one is predictive. So reinforcement theory, the original Skinnerian work, is about prediction, probabilities of behavior, and control is the follow-on to that. So those are all sort of scientific theories that we can see and understand. The theory that I'm interested in, that we're interested in working on, is the notion of generative theory. And this becomes interesting because we're in this evolutionary process. We generate new things, and it matters what was generated before and what our theory does to help us generate something in the future that we think of as better. And we have value judgments here. Generative theory is about critiquing and measuring whether we've had a positive impact or a negative impact. So we have this paper called Generative Theories of Interaction. This is with Michel Baudouin-Lafont and Susanne Bodker at Aarhus University and me. And basically the idea is a very practical approach to how to take broad theories and actually have a positive impact on specific design. So the approach is basically we start with the notion that there are theories out there in the world. Evolutionary biology, I use coadaptation that you mentioned. There's other ones out there, tool use, human tool use. These are theories that are defined by people outside of our field, legitimate scientists who do science. And what we do is we take concepts from there that are relevant to what we're trying to do as people doing human-computers interaction design. And then the critical bit is that we do generative principles. And that's the critical transition for me. A generative principle is one that is specific enough and that you can understand it and it's actionable. That means that I can tell somebody, here's this principle, and if you apply it, you can think about how to make this thing better. So it's not just because, and I should say just as an aside, I used to teach about theory in HCI, and I used to ask people to design things, and they'd think about the theory, forget it, and design stuff that didn't take it into account. And this is specifically, I have another paper that I did with Danielle Lotridge a number of years ago on generative walkthroughs. I'm not going to go into methodology here, but there's a lot on that. But the idea is how to take these kinds of generative principles and systematically apply it to your design process so that you actually know whether you're doing something that follows the theory. All right, so once we do that, we have three lenses. We have an analytical lens, which basically allows us to look at a particular artifact that exists already and analyze it from the perspective of these generative principles. So it gets very concrete. The second thing that we can do is take a critical lens. And now we're starting to do value judgments. The analytical lens is just, does it exist? Is it there? And we can figure that out. Critical lens is, that's better. Not sure. What happens if we do that, right? And so that's, again, looking at existing artifacts. Now, what's interesting is we can also apply this critical lens to revisions or future artifacts, things that we're going to make better. And so, again, now we're applying these principles in a way that we can make value judgments and say, we think that this will be better. And we can always test them. And finally, this is the generative lens. I was getting ahead of myself. The generative lens allows us to then take these principles and create new things. And a lot of our research over the past decade has been really applying these kinds of principles to create things that are much better for users that take these principles into account. And so that's the overall picture. If you wanted to take a picture, that's the better picture to take. Sorry about that. Okay. And I'm not going to go into it. It's always terrible when people say that. But if you look at my original drawing with the theory, artifact, and observation going back and forth, the simplified version, generative theory is really sitting at the top there. We're looking at, okay, how does theory affect the design of artifacts? But we also have a set of design methods, which is not the purpose of this talk today, but looking at how do we go about observing and measuring whether users have actually been able to take advantage of these theories. So we do that as well. So it's a complete picture. And in case you're wondering, here are some examples of some of these generative principles. So this is based on a few things. There's basically instrumental interaction, which comes out of a paper by Michel in 2000, and then some follow-on work that we did together on reification, polymorphism, and reuse. Reification allows me to turn a command into an instrument. So if I had on my computer a command that says amplify voice, and I could click on the amplify voice command, and it would amplify my voice for whatever period, and then I'd be done. Or I can turn it into a persistent tool like this one or this one. And now it's something that persists, and it's reified into an object that I can now manipulate and use. And I have far more powerful interaction with the same level of simplicity, back to the power simplicity curve, if I have something, a tool like a microphone, rather than having to keep pressing some button somewhere and saying, amplify my voice, amplify my voice. And if you look at most interactive systems today, a lot of them are in the press the button and amplify the voice rather than having the tool. So there's a whole set of these. I'll talk a little bit more about co-adaptation in this talk. I won't go into all of that stuff, but there's really quite a wealth of material that's out there. All right, so now I'm going to go back to this. What do I mean when I say co-adaptation? Where does this come from? What does it mean? Well, it comes from Darwin, way back when. This is evolution. But it's not co-evolution, it's co-adaptation. So there is this notion, and it's actually really nice because Lovelock and Margulies did a nice thing that really sort of launched our way of thinking about the planet as something that we have an effect on, and for better or for worse. But this is based on this idea that organisms co-evolve to influence the environment, which in turn influences evolutionary process. And the simple example is, in the beginning, they had anaerobic bacteria. Those were the first ones to be created. It turns out that anaerobic bacteria produce oxygen. And so that created an oxygenated environment, and then other bacteria evolved that need oxygen. So now we have both. So that is coevolution. It happens over many, many years. So we're talking millennia, eons, lots and lots of time. So that's one phenomenon. That's not the one I'm talking about. All right, so coevolution, two or more species adapt to each other over long periods of time. I just want to say, everybody talks about evolution like survival of the fittest. Great, but part of that survival process is changing the environment in which you are being fit. So human beings, we create houses, we do air conditioning. We change our environment so that we survive better. And that's actually one of the things that human beings are pretty good at. Although what I just described. All right, so it's not about survival of the fittest. Let me not go off on a tangent here. Let's just get here to co-adaptation. The second one is co-adaptation. So in Darwin, there is also this notion that individuals in the course of your lifetime, in short periods of time, they adapt to the other animals and other parts of the environment. And that co-adaptation is that shifting, changing back and forth that is really critical here. And if you think about how we interact with technology, we're doing two things. We're adapting our behavior to it. It's been designed to have us do certain things, and we adapt to that. But we're also changing it. And that's what I want to highlight on. So what the vision here is take advantage of this underlying principle that exists and make it a positive relationship when we're dealing with people and AI. All right, so basic pieces are, if you are going to adapt to a piece of technology, you need to discover what it can do. So that's discoverability. You learn also how to express yourself, like how to use it to do the things that you want it to do. So not just how does it work and I sit back, but how do I express my needs with it? On the other side, we have this notion of adaptation or appropriation. This is where things get interesting because we customize the technology that we use in lots of different ways. If I ask you, have you ever been in a graphical, like you're creating a slide or you're doing something graphically on your computer, have you ever tried to align things by making a box and just aligning them, right? That is adaptation. What you're doing is you're taking advantage of the fact that there's a, verticalness to that box that's aligned, And you can use that principle, that property, excuse me, of box to align things, right? We do this all the time. We do this in the physical world a lot. In the digital world, the systems are not designed to let us do that. But the argument is maybe we should. So we have people customizing technology, and we also reinterpret and appropriate the technology to innovate. So that's the high level view. So that's a summary. Now, all of what I just said is looking at how do we think about what is possible with this technology. So we want to have some sort of future action available, and also an effect. What did it just do? So feed forward is what can it do next, and feedback is what did I just do. This is a system that's getting old now, from 2008, but I like it because it's a simple example of this. Basically, if I have my phone, I don't have my phone here, but anyway, I have my phone, all of you have a phone. Right now, phones are very much button and typing. You know, we press buttons and we maybe have a menu every once in a while. There's a lot of things that I would love to be able to do with a gesture. You know, why don't I do that? Well, because I'd have to learn how to do it, and the learning curve is too high. I can give a cheat sheet, but I don't know if you've ever looked on the Apple thing where you have, like, if you have 3 fingers and you do this, and you have 4 fingers, you do that. I don't use it, it's too hard. So what I want is something so that if I already know how to do it, I just do it. And that's things like zooming and, you know, resizing a picture. It's what we call one trial learning. That works. I see it once, I go, oh yeah, okay, now I can remember it. But if it's a complicated thing like 3 fingers in a circle, I'm not going to remember. So what I want is a system that helps an expert just do it and a novice learn, and a novice learn at the moment when they actually need that. So we have this thing called Octopocus, and this is based on the observation that if I don't know what I'm doing, I hesitate. And if I hesitate, then I get what's called a dynamic guide. Here we see a dynamic guide, but I think I'm going to just jump to the video and hope that the video, get this here, play. Are we getting sound? Not getting sound. I can do this. All right, well, I can voice over. All right, so the idea is that if you're a novice, of course now it's done it, but it'll do it again. It goes here, I start, I pause, and it shows me possible continuations in the moment. And it says, oh, if I go that way, I call Alice, and go that way, I go to work. And it gets rid of things that are no longer probable. And so I'm basically just dynamically doing it. And here, it just works. So if I'm the expert, I know that calling Alice is always that thing. Now, let me see here. Come on, computer. Yes. All right. So another thing that I like is this notion of expressivity. And this is a little bit of reinterpreting what the problem to solve is. All right. So a friend of ours, Shuman Shai, invented something really cool called gesture typing. And the idea is that we're thinking about, well, my goal here is to do with expressivity. I want to be able to take advantage of the fact that each individual human does things a little bit differently. If you're a musician and I play the violin and Michelle plays the violin, it will sound different. Maybe not the best example there. All right, so let me show you something that we did with gesture typing. So there's a machine learning system, and it defines the goal as figure out what word is there. What's the right word? Okay, great. We saw an example of that earlier. But the way it works with all of the systems that are out there is anything that is human variation is treated as noise, something you want to get rid of. And we said, well, wait a minute, that's an expressive difference. Maybe some of that noise is something that could be controlled by the user, just as a skilled musician controls that variation to have different kinds of expressive output. So I think I'm going to just show the video because it's easier, but this is not playing quite as nicely, so I have to find my mouse. which I do. All right, will that play? Yes, okay. So this is what gesture typing looks like. You can see coming up here. And you're noticing that what she's doing, she's changing the color. I'm going away here. She's changing the color and she's changing the font. So we worked with a professional typographer to get this really nice set of fonts. Oh, we are getting a little bit of sound. Ah. So what we've done is we've mapped different kinds of gesture variations to things like the font style here. And so she's controlling all of that. And we have little indicators up there, that line of numbers that allows her to know what she wants to do. Here it's being attached to the accelerometer on the phone. So it's got this very bumpy font, which is kind of cute. And just, he's doing this in a very elegant way. He likes this thing. And then she's saying, and the idea is that this is all, you know, I mean, emojis have taken over, right? The idea is that you want to be able to do expressive things, but in the process of doing it and not have to do a lot of learning to make it work. So that's another example. Let's see what we've got here. Adaptation, customizability is another thing that we want to do. So this is still with the same theme of what can you do on a phone. If I'm going to have these personalized gestures, it would be really nice if I can say, this means call Alice, not just call home, which would be defined by Apple or whoever. So how do we do that? Well, what we need to do is balance a trade-off. The system needs to be able to find a gesture that is unique and different from everything else that's in the database of gestures that it's got. So it needs to be able to distinguish one gesture from another. And the user needs to be able to remember it. And those are two different things. So how do we create one gesture definition system that allows us to do that? So what we do here is we create a heat map that goes from blue to red, and I will let the video explain that. And for some reason, let's see if we can get the sound up. Okay. So if it stops in purple, I can barely hear it, so you probably can't at all. If it stops in red, that means that the gesture already exists. And if it stops in purple, that means it's ambiguous. And if it stops in stone, then yes, this particular gesture does not already exist, although the one before does. So here, he's defining call Alice as the Google thing. And oh, no, that won't work. So let me try something different. And that works because it's blue. And so basically the idea is that we're taking advantage of how people and systems need to learn. That's a partnership there. We have different expectations, different needs, and so on. And finally, I'm going to do one on appropriability. And this is what we call command board. And the idea here is that we want to transform the space above that soft keyboard into an interactive space. So instead of having it just be an output space, now we can make it an interactive command space. And here we want to have something where any command that's available on my phone, I should be able to just write the command and say execute it, and then done. It should also be able to be discoverable the way this Octopocus thing did, and I should be able to redefine it. So let's see if we can see the video. And again, it's difficult because you're not getting the sound, but I will. There's a thing up here, but it goes away whenever I try to touch it. Okay, so what's happening is you can do this type and execute. So I can type a word, and it pops up the thing that says execute. Execute is just this gesture. We have gesture shortcuts, which is fairly similar here. And we have the party was great, and then we have this same kind of thing. So in the same interface, we can provide all kinds of different levels of scaffolding for the user to learn how to do these things. And here, this is one where they're executing the doodle command, and the idea is that I can now draw on the space above. And the party was great. And these are different ways of different gestures that affect the word great. You can have bold, italic, strike through, underline, and just, again, in the process of doing it, burn it. And then we'll see this again. All right. I think I'm going to stop there. This is not, come on. There we go. Okay, so we have these different principles. The idea that we can adapt to the technology, but we can also adapt the technology. We want to think about designing systems in such a way that there's a clear path for the user over time to learn these different kinds of things. And basically, I have two, I'm probably really late on time, aren't I? Pretty late. Yeah, I can see from your face. All right. So all the stuff I just talked about didn't require much AI. But what happens when the AI is also an intelligent agent who's acting back and forth? So now we have to think about not only the user adapting to the technology and adapting it for their own purposes, appropriating it, but the AI side can also learn about the user and modify the user's behavior. So I have two quick examples. They're not quick, but I just want to show them. All right. So the first one is something that we did that's more fun. We worked with a theater company in a place outside of Paris. We did this several times in several big installations. And the idea is that we want to have passersby during Christmas time to learn how to animate Santa and do a particular thing. In this case, we want ordinary passersby to put their hands over their head, and we don't want to tell them that that's what we're training them to do. So we have a whole thing that's based on my early days of being an experimental psychologist and this whole idea of how you share control with the system, but the system is going to shape this user's movements to control this animated character. This is what the reward is. This is, oh, please play, please play. Where is my, do you see a cursor there? Yes, you do. Okay, so that means it's down here somewhere. Please, there we go. Okay, so this, it makes a lovely noise too. This is what the theater company did. They did this magnificent animated machine, very squeaky, and it's creating all kinds of little different Santa Claus characters. And as you walk by, Santa stands up. We had the animator design this character here, and that's the reward. So we're doing interactive reward, and it's really cool to get that going. Now, what we do is we basically work on the notion of behaviorism, and we use what's called successive approximations to the final behavior. So if the movement is almost correct, Santa moves up one of these staircases. So once the Santa is there, we want him to move up, and then this thing here is actually, I can't move, I'm not tall enough, but there's a big lever at the very, very top that is a physical lever, and the animated character will grab the physical lever in theory, and it will come down, and then it will launch everything. All right, so when you see the stairs, you want to go up the stairs. That's just what you do. So, come on, this is not a good example of combining two different technologies, and now PowerPoint is not operating. So, all right. So this is done by trial and error. That's fine. And there's several things. So the thing that we discovered is if you're going to be doing an animated character in a big public display, and the animated character just imitates what the user does, that's interesting for 30 seconds or less, and then people walk by, and they just don't. I mean, it's like, yeah, okay, it does it. Fine, I can make it do that. But we start with the mirroring just to show people that it's paying attention. It's got you, it knows you're there, you play with it a little bit. Then Santa gets bored. So Santa's been paying attention, follows what you're doing, and then he does this. And what that does is it prompts what's called extinction behavior. This is the behavior you get if you're at a Coke machine, you put in the money and it doesn't work. More behavior. That's extinction behavior from the theory of behaviorism. And so what happens is they start doing more movements. And now from those movements, we can reinforce movements that are closer to the final behavior. So this is the notion of successive approximations to the correct movement. And then here is an example of, I'm not going to play it, but basically we have Santa. We're using a small Connect, very, very simple. This is when it was being played in the, oh, please play. There we go. Actually, she's great. This young girl came back. We had it for 3 days in the chateau, where c'était Chiffre-sur-Yvette, CNIS, and she came back every day and played with it. You can see she's a little bored, but anyway, she got it to the point, the 30 seconds, and she's now got this going, and she's got her things down. She's got her hands above but down, above and down, so it's kind of like, are you there? Not yet. Okay, she's doing it. She's moving up, and she's going and going and going. It's like, there she's going to go. And then she has a whole set of different things. And what we're doing is you can see here, when it's red, that's a good thing. It's blue. So now she's doing her Egyptian move. Right. I love that. And the point is that then it goes and gets to the virtual handle, which then launches the machine. And she's done it so many times, she's now bored. It's okay. Anyway, we have this little girl who does it. She's just really cute. So there are a lot of different methods for doing it. This is as much to prove that we don't have to explain what's going on. We can just get people to make these moves. And now her hands are up there, and it has to be over a certain period of time. And so there she goes. And now you can see it actually launching. All right. So you get that idea, and I'm really out of time, so I'm going to not go into much detail here. But this is a very different kind of thing. This is using Bayesian information gain. And the idea is that what we were doing before is not telling the user what we were doing, and we're manipulating their behavior. This is what social media is doing to everybody all the time. This is a different one where we're challenging the user. We're saying, you want to navigate through a space as quickly as possible. And we're going to use our understanding of what you've already done and make the most challenging set of options for you so that if you choose one of them, it provides the computer with the most information. So we're trying to maximize information gain. So this is basic. I'm not going to go into the details, but it's a fairly simple issue here. What we do is we create a navigation, and we want to go from Denver over here and identify, I think the answer is New York. And if you're using a normal system, what you would do, and this is a really limited system, so all you can do is go left, right, up, down, and move the frame. And a normal system would just have you slowly go, dun, 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 and you go there. So the goal here is to get to New York, right? And you have a little frame. Now, these are the actions that you can do. There's 8 pan directions and 1 zoom direction that you can do. And now we're trying to get to the New York. New York is the intended target from Denver, Colorado. What's interesting here is that we make the assumption that users make errors some of the time. So 5% of the time they make an error. So sometimes people will go in the wrong direction. We have to take that into account. All right. And so basically what we're going to do is we're going to update the system's knowledge every time the user makes an action. And we're going to try to navigate to a new view that maximizes the amount of expected information gain. And so here, there's 4 different possible views, and the user has to pick one that will do that. Okay, so the one that maximizes information gain is the one that shows these 2, which is not intuitive. It's not move here, it's show me this, because I could, if I'm going to Kansas City, it's closer there. If I'm going to New York City, it's closer there, and it could be one of those. So it has fewer moves to actually get to the final spot. Anyway, and that's the optimal. All right, is this a video that I can play? Right, so this is a little hard to see, but it's 3 steps to go to Paris. So it zooms in and gives you that view. and then it goes here, and then we get to Paris. I think this is probably something that I should not have spent so much time on because it's harder to understand. Anyway, the idea is that it's 40% faster than Pan and Zoom, but it's higher cognitive cost for the user. So there's a trade-off there. But it's something that you can think about challenging the user in, for example, in a safety critical system. If speed is critical, then you have to do one thing. If cognitive load is an issue, then you have to think about that, and so on. So that's just the paths to getting rid of this. All right, so let me go back and finish up. Basically, my argument is that we need to be creating symbiotic relationships, that we want to think about how do we create interactive systems where the AI benefits humans and less worried about humans benefiting the AI or helping the algorithm. And I draw back again to this analogy with evolutionary biology. One of the things that's interesting about that is that they think about species interacting with other species, and you can think of human beings and AI as, in some sense, a species, two different species. But the important point here is that the relationship could be positive, neutral, or negative. And so we have symbiotic doesn't necessarily mean positives. It's a mutualist symbiotic relationship that is positive. And then we have, parasitic and other kinds of things. So we can think about lots of different ways of creating these types of interactions in a positive way. So we don't want, there are going to be cases, I suppose, where you want the intelligent system to replace the user. A lot of them that are out there right now are significantly lowering people's skills. And what I'm interested in, and I think there was a question before we started about, so what's the impact of this on HCI? I think the impact is we need to show the world how do you use AI to enhance human skills so that the human being and the user together are better, and that we're using AI to upskill rather than de-skill users. And this is kind of like, do we want the robots replace us kind of future? Do we want the WALL-E kind of life of ease future? Not really. Are we scared of AI? Well, sometimes. Or this is on Sophie Buter, and she's playing a violin, and I would just love to be able to have an AI help me play the violin like her. I probably won't, but it would be very nice. So anyway, that I will now take questions. So there was a question back there. I don't know if you still want to do it or.
Yeah.
Sure. I'll go back to Anne-Sophie.
Thank you for your presentation. So my question that I was going to ask was this one slide describing or encouraging ChatGPT and
right.
How it's the same algorithm. I would sort of challenge that because I think ChatGPT really is the first instance of using RLHF, so reinforcement learning with feedback, as opposed to just next token discovery, being able to produce images. So the algorithm did change. And it's interesting you brought up this example because to me that was one where I feel there's an interesting challenge to the dichotomy between AI and HCI.
It does, yes.
Because RLHF to some extent is trying to design an algorithm that is such that it adapts to, or at least, or it's better adapted to a population of human beings that tends to produce, sentences that are helpful or appreciated by a person. And it's also interesting because language is both the output and the interface of an individual. And so it does cover both, if you just think of the AI as producing outputs versus HCI focusing on the interface. It's sort of working. So I'm trying to hear some of your thoughts of where it seems like this dichotomy is sort of being challenged.
Well, fair point about that. The thing that I think is at the global level, GPT-3, it was GPT-3, and then they modified it so that they could do ChatGPT. So yes, I need an example when I'm talking to different audiences that is sort of quick and easy to understand. Because people thought that it was brand new, and the fact that GPT-3 had been around for a couple of years before is not common knowledge. But yes, of course, it had been evolving, and that's an evolving system. And so if I jump further in my talk and talk about the fact that these things are evolutionary, those things are changing rapidly all the time. One of the things that I didn't get into is this notion of language. And there's a lot of assumption, and I've gotten this from talks and various people who say, well, now that we can talk to the computer, we assume that it'll always, I mean, eventually, if we have the right model, it'll just always understand us and it'll just know it, which I don't believe. But even if we had that, there are many, many, many things that we do as human beings for which talking is not the appropriate style of interaction. And the question is, how do we do all those other things as well? And, take advantage of the fact that we have, that we can move and we can draw. If you ask an artist, so we do a lot of work. We do work with two different kinds of groups of people. We work with people in safety critical systems, so pilots, air traffic controllers. We've done, that's old stuff, but more recently we're working with RTE, which is a French energy grid control rooms. We work with doctors. We have a number of different kinds of things. Did I say pilots? Yeah, pilots. And so that's one set of things. And by the way, we have a postdoc available. So if anybody's interested in doing a postdoc with us, looking at both doctors and pilots and looking at fixation bias relative to that, please do come and talk to me. But the other group that we work with are creative professionals. So we work with choreographers and people working in theater companies and musicians and those. And those two groups are particularly interesting to us, I think, because they push the limits of the technology and they force us to think about things from a different perspective. But anyway, your point is, I won't argue with your point about GPT. I oversimplified for the purposes of the talk. There's many things that are oversimplified here. So, I think the more general question is, when is it not appropriate to talk, and what happens when the AI is doing something that's plausible but not right? And in a safety critical system, that's a real issue. In a creative system, it can be interesting. So it matters who the user is. Yeah.
Thank you for the talk. Maybe building on what Hugo said,